Hello everyone, welcome back to the video. So due to a very unfortunate power outage, we really didn't get through too much today. So I'm going to talk about what we did get through and then we'll go from there. The aim for today is how can we solve specific heat problems? You're due now. How do you convert 30 degrees Celsius to Kelvin? What we do is we take 30 and we add it to 273 and that gets us 303 Kelvin. So, you do not have homework, just make sure you stay safe for Halloween. So, here's an interesting problem. Let's say you're making a pizza. You put the pieces together, you put it in the oven, you cannot wait to eat it. As soon as you take it out of the oven, you wait a good amount of time for it to cool, and then you take a bite. But ow! You burn your mouth while eating the pizza. But if you bit the crust, you wouldn't have burnt your mouth. Why? Think about the specific heat of the cheese and the pizza crust. The answer? The cheese has a higher specific heat capacity than the crust does. Specifically, the reason why for that is because the cheese takes in more energy than the crust does. Therefore, the cheese will hold more energy than the crust does, so it'll take longer for it to cool down. So I know that you guys copied this yesterday, but, just to give you a little bit of a friendly review. This is your formula for your specific heat capacity. This is how to determine the heat gained or lost by water. So your formula is Q equals mc delta T. Your M is for mass, your C is for your specific heat capacity, which can either be in joules per gram Celsius or joules per gram Kelvin. We'll talk about that in the next slide. But this formula can be found in table T, and the constant for water can be found on table B. Now here's the important note. 4.18 joules per gram Celsius is equal to 4.8 joules per gram Kelvin. Basically, the C value is the same whether you have Celsius or Kelvin, so you do not have to worry about any kind of conversion when solving these problems. Just a little heads up. So first example. What is the total number of joules of heat energy absorbed by 15 grams of water when it is heated from 30 degrees Celsius to 40 degrees Celsius? So, first thing I want to note, the way that we know that this is a specific heat capacity formula is if it gives us a numerical temperature value. And when I say numerical, I mean that it gives us a number temperature value. So it's telling us 30 degrees, 40 degrees. The fact that there's a number in there is a sign that we're using the specific heat capacity formula, which is Q equals mc delta T, which some people call it MCAT. So let's write what we have. We're given our mass, which is 15 grams. We're given our temperature change, which, by the way, I'm going to write up here. Your temperature change is equal to your second temperature subtracted by your first temperature. So it's heated from 30 to 40. So you're subtracting 40 minus 30, and that's equal to 10. So your change in temperature is 10 degrees Celsius. Now for your C. You can find C on table B of your reference table, so let me pull that up real quick. So again, always on the top of your classwork. And on table B, we see that the specific heat capacity is 4.18. So it is 4.18 joules per gram Celsius. I know it says Kelvin on the table, but you could still use Celsius. So you're looking for Q. So we're going to write out our equation. So that's Q is equal to 15 grams times 4.18, and that is joules per gram degrees Celsius. And we're timesing that by 10 degrees Celsius. Now we can rule out the already used units, because that tells us how many units we have left for our final answer. So grams are gone, grams are gone. Got that, guys? Celsius is gone, Celsius is gone. So that means that our final answer is going to be in joules. So now we're going to multiply these values real quick. So that is going to be 15 times 4.18 times 10. And that comes out to be the joules being 627 joules. Now, you're going to look at this answer and go, oh no, that doesn't match any of the answers. That's going to happen sometimes on the test. Sometimes they're going to give you an estimate of your answer rather than something that's exactly on the dot. So which answer is the closest? D. So let's try some problems together. So we're going to specifically go to page 7A of your Meta-Energy packet. To find it, what you do is you're going to go into, you're going to press classwork on the bottom. You're going to click on, you're going to go all the way down to Meta-Energy. You're going to click on the Meta-Energy packets right over here. And then you're going to click on the first link, so this one up here. And then you're going to go to page 7A, which is right here. We're going to do some of these problems together. Okay, let me just erase this top one so we can start fresh. Okay, question 1. When 25 grams of water is cooled from 20 degrees Celsius to 10 degrees Celsius, what is the number of joules of heat energy released? So again, because they're giving us numbers for the temperature, we are going to be looking at the Q is equal to mc delta T, or MCAT. So, we're given our mass, which is 25 grams. We're given our C always, which is found on table B of the reference table. That's just the 4.18 joules per gram degrees Celsius. And you're given your temperature change. So to find your temperature change, remember it is delta T is equal to temperature 2 minus temperature 1. So in this case, it is going to be 20 minus, is going to be 10 minus 20, because remember, the 10 is our final temperature. So it's going to be 10 minus 20, which comes out to be negative 10, and that is what is our change in temperature, negative 10 degrees Celsius. So now we just plug it into our equation, so that is 25 grams multiplied by 4.18 joules per gram degree Celsius times negative 10 degrees Celsius. Again, we can cross out our units, so grams, Celsius, Celsius, so we're just left with our final answer being in joules. So now if we multiply these values real quick, that is going to be 25 times 4.18 times negative 10. That comes out to be negative 1,045 joules. And that's your answer. Next one. How many joules of heat energy are released when 50 grams of water are cooled from 70 degrees Celsius to 60 degrees Celsius? Okay, so again, we see that we're given a number temperature value, so because of that, we are still using our Q is equal to mc delta T. So, we know that our mass is equal to 50 grams. We know that our C is the same as always, 4.18 joules per gram degree Celsius. And we know our delta T is going to be 60 minus 70, which is negative 10. So, now again, we're just going to plug everything into the formula. So that is, I'm going to do this in a different color. $50 grams times 4.18 joules per gram degree Celsius times negative 10 degrees Celsius. So now what we can do, again, we could rule out our given units. Take that away, take that away. Take the Celsius away, take the Celsius away. So again, our final answer is going to be in joules. So again, all we have to do is just multiply those three numbers. So we're doing 50 times 4.18 times negative 10, and that comes out to be negative 2090. And that's your answer. Let's do another one. What is the total number of joules of heat energy absorbed when the temperature of a 200-gram sample of water is raised from 10 degrees Celsius to 40 degrees Celsius? Again, because we're given that number temperature value, that means that we are going to do our Q is equal to MC delta T. So we have our M, which is 200 grams. We have our C, as always, 4.18 joules per gram degree Celsius. And your delta T in this case is going to be 40 minus 10, which is 30. So our delta T is going to be 30. So now again, we plug it in. So that's 200 grams times 4.18 joules per gram degrees Celsius times 30 degrees Celsius. And again, we just multiply these numbers real quick. So that is 200 times 4.18 times 30, and that is equal to 25,080 joules. Again, I did not go over it, but just so we can clarify, you can eliminate any units that are reused. Grams, grams. Celsius, Celsius. So you're left with joules. Now, what if they're asking you not to solve for the energy? What if they're asking for something else? For example, let's try number 4. Number 4 says the temperature of a sample of water in a liquid phase is raised to 30 degrees Celsius by the addition of 3,762 joules. What is the mass of the water? So, let's see what we're given. Here we're given the change in temperature just right away, that it's being raised to 30 degrees Celsius. So your change in temperature is 30 degrees Celsius. We always know our C, which is again 4.18 joules per gram degrees Celsius. It also gives us a joule value, which we know is our Q. So our Q in this case is 3,762 joules. So now we're left to find M. So let's plug everything in. So that is 3,762 joules is equal to X times 4.18 joules per gram degree Celsius times 30 degrees Celsius. So if we go in and delete what we already have, joules are gone, Celsius is gone. So your final answer is going to be in grams. So now let's solve for X. So we do 4.18 times 30, and that comes out to be 125. X is equal to 3,762. So now we need to divide both sides by, oh, I'm sorry, it's 125.4. Let's fix that real quick. So divide both sides by 125.4. And when we do, we find that our X value is equal to, hold on one second, 3762 divided by 125.4. That comes out to be 30 grams. And that's our answer. We'll do 2 more problems and then we will call it a day. So, number 5. When 418 joules of heat are added to 10 grams of water at 20 degrees Celsius, what will the final temperature of the water be? This is a tough one, but don't let it trick you. We know that it is going to be a specific heat capacity because, again, it gives us a numerical temperature value. So, let's see what we're looking for. We are given our energy, so our Q is equal to 418 joules. We are given our mass, which is 10 grams. And now this is giving us our original temperature. It's not giving us our final temperature nor the change. So that's what we're looking for. We're looking for our delta T. So again, we use our C value, which is 4.18 joules per gram degrees Celsius. So now we're going to plug everything in. So that is going to be 418 is equal to 10 grams times 4.18 joules per gram degrees Celsius times X, because we're trying to find that change so then we can figure out what the final temperature would be. So what we're going to do is we're going to multiply 10 by 4.18. So 10 times 4.18 comes out to be 41.8. And that's X is equal to 418. Divide both sides by 41.8. And when you divide them, your X comes out to be 10 degrees Celsius. So to find your final temperature, all we're doing is adding 20 degrees Celsius plus 10. And so your new temperature is going to be 30 degrees Celsius. And that's your answer. And final question. What is the total number of joules of heat energy absorbed when the temperature of a 50-gram sample of water is raised from 150 to 200 degrees Celsius? Okay, so we are given a temperature value, therefore we are going to be using our Q is equal to MC delta T. So we are given our mass, which is 50 grams. We are given our C, which is 4.18 joules per gram degree Celsius. We are given our delta T, which would just be 200 minus 150, which would be 50. So our temperature would just be 50 degrees Celsius. So now again, we're going to plug everything in. So that is 50. So Q is equal to 50 times 4.18 times 50. So again, you're going to multiply these values with each other. So that would be 50 times 4.18. Sorry, 50 times 4.18 times 50. And that comes out that your Q is equal to 10,450 joules. And that's your answer. As always, thank you for listening. At this point, what I'd like you to do is I'd like you to go to the exit ticket. And the exit ticket for today is asking you to solve the following problem. How much heat must be added to a 350-gram sample of water to raise its temperature from 44 degrees Celsius to 100 degrees Celsius? Go ahead and give that a try. Show your work. I have changed the due date for the exit card, so now it is going to be due at Sunday at 11:59 p.m., so make sure you get it done before Monday. And as always, thank you for listening, and I hope you guys have a wonderful, wonderful day.